Hello and welcome to this video on how we multiply and divide numbers in the octal system of numbers. So we're going to be looking at how we can multiply two octal numbers together and divide one octal number by another. We'll start with multiplication, and before we get to the octal system of numbers, I want to talk briefly about the method of long multiplication that we're going to be using, and we're going to start with just a very simple example of normal decimal numbers that we might use every day in order to just become a bit more familiar with the method that we're going to use. So let's say that we want to multiply 67 by 4. Now, I don't mean this to be patronizing at all. I'm sure you can all multiply 67 by 4, but it's the method that we're going to be looking at because it's going to become important when we're looking at the different number systems. So let's set our long multiplication up like so. We have 67 multiplied by 4. And what we're going to do is follow the method of long multiplication step by step, just to multiply these two ordinary decimal numbers together. And then we're going to use the same process to multiply two octal numbers together as well. So the way we do this is we start with the right hand column. We're going to multiply 4 times 7, and 4 times 7 gives us 28. When it comes to our method, we have to remember here that we're dealing with decimal numbers which are to the base of 10. So I'll just make a little note above here. We have a base of 10, and that means we're going to carry tens to the next column. Let's see what we mean. Since we have 4 times 7 gives us 28, we can carry the tens to the next column. So we have two tens, as it were. And what remains is going to be the 8, which goes down here. So let's put these in. We have, we're going to carry the 2, and we're going to put the 8 as part of our result there. The next step is to multiply the other combination, which is 4 times 6. We've already done 4 times 7. We're doing 4 times 6, and 4 times 6 gives us 24. But what we have to remember to do is to add the number that we've carried on the end as well. So 4 times 6 gives us 24, and adding that 2 is going to give us 26. And so our number is going to be 6, and we're carrying another 2 to the next column. Well, that next column now, it only has the 2 in it. There was nothing else in it to begin with, and so we only have 2 as our result there. And so finally, we can say that 67 times 4 is 268. Let's have another example. So here we have another example just involving decimal numbers for now. We'll talk about octal numbers in just a second. But we have 28 times 34. And again, we start with the right-hand column here. So we're going to say 4 times 8. And 4 times 8 gives us 32. And so repeating the same method as before, 32, we're going to carry the 3, and we are going to put the 2 as part of our result here. The next combination is, we're just dealing with the 4 on the bottom here to begin with. So 4 times 8 we've done. 4 times 2 is next, and 4 times 2 gives us 8. Not forgetting to add the 3 on the end. And so we have 8 plus 3, which gives us 11. And so again, we put the 1 in here, but we carry the 10 to the next column. And that last column only contains the 1, so we have our result there. But you'll notice that we've neglected this 3 here, which hasn't come in to any of our calculations yet. We've just done 4 times 8 and 4 times 2. The next set of multiplications that we're going to do are multiplying 3 by 8 and 3 by 2 to give us our complete result. And so we're going to do the same thing again. The only thing I'm going to do is I'm going to remove these numbers that we've carried, because we're going to do another set of results now. And what we're going to do is we're going to say that 3 times 8 is our first multiplication, and 3 times 8 gives us 24. And so we're going to carry the 2 to our next column. So I'll put that in here. The 4 from the 24 is going to be put here. I'm not putting it in this column here because we're now dealing with the tens, as it were, rather than the units. So we're multiplying everything by, as it were, 30 really, because this 3 is in the next column. And so everything's going to be pushed to the left once. This space here should be blank. Sometimes you might even see people put a little dash in there to remind themselves. So we're starting from this position here, shifted one place to the left now. But anyway, we've done 3 times 8 gives us 24. So 20, the 2's been carried, and 4. Next up, we've got 3 times 2, and 3 times 2 is 6. Not forgetting to add the 2, which is 8. And so our next result is going to be 8 there. Lastly, the final step is just to add these 2 together, because we've got one set of results from doing 4 times 8 and 4 times 2. And then we've got another set of results that we've just done there from 3 times 8 and 3 times 2. We just add them together. 2 plus 0 gives us 2. There we go. 1 plus 4 gives us 5. And 1 plus 8 gives us 9. And so we found our final result there. 28 times 34 gives us 952. Okay, so apologies if that's a little bit obvious to everyone. I'm sure you know how to multiply, or at least you can use a calculator to do so. But this particular method of long multiplication is important because we're going to use this same method in order to multiply our octal numbers, and in future videos we're going to be multiplying things like hexadecimal numbers as well. But the reason I wanted to use this particular method and show a decimal example is when it comes to carrying these numbers, which we see up at the top here. For example, we've carried that 2 there. Our decimal numbers are to the base of 10. And so what we're really doing is we're carrying bases of 10, as it were. When we carry 2, what we're really saying is 2 lots of 10, as it were. We're carrying 20, as it were, from the result of 24 there, for example. We're carrying 2 lots of 10, or 2 bases, as it were, when we're in the base of 10. When we're in this octal system of numbers, octal numbers are to the base of 8, and we're going to have to take that into account when we carry our numbers like this in the next example. So let's have a look at what we mean. So here's an example of 2 octal numbers that we're going to multiply together. Let's suppose that we have the number 352 and we're going to multiply it by the number 46. And these are octal numbers. So notice I'm not calling them 352 or 46 because that's not really the same thing. That's a decimal number, whereas these are octal numbers. Again, if you're not sure about octal numbers, it's worth going back to the video where we introduce octal numbers in a bit more detail. But for this example, we're going to repeat exactly the same process, but remembering that our octal numbers are to the base of 8, and that's going to become important when we start doing things like carrying numbers. So let's start again like we did with the right-hand side. We're looking to multiply 6 by each of these digits first of all, starting with 6 times 2. 6 times 2 gives us 12. And again, we're going to have to carry to the next column here. But remember, we're not in the base of 10 anymore. We're in the base of 8. And so what we're going to do is we're going to carry one lot of 8, as it were. And so we had 12 here as our result. We're going to carry one lot of 8, and that's going to leave us with 4, because we had 6 times 2, giving us 12. We've carried 8 worth of that to the next column, as it were, and so that leaves us with 4 left over there. Let's have a look at the next combination, because we have 6 times 5 as our next multiplication. 6 times 5 gives us 30, not forgetting to add the 1, and so that gives us 31. So then, now that we have 31, we're obviously going to have to carry some number to the next column. And so the way to think about that is, how many 8s are we going to carry? Well, 31 is made up of 3 8s plus an additional 7. So let's just write that out to the side here just to make it clear, because we can say that 31 is equal to 3 lots of 8 plus an additional 7. And so what we can say is we're going to carry 3 lots of our base to the next column, leaving 7 in our result. So let's do that here. We can say that we have 7 forming our next digit here, and we've carried 3 lots of the base to the next column here. So next up is, we've done 6 times 2, we've done 6 times 5, we're now going to do 6 times 3. 6 times 3 is 18, plus an additional 3 is going to give us 21. On the right hand side again, we'll make a little note, because 21 is made up of 2 groups of 8, which gives us 16, which means there's another 5 left over. And so we're going to carry those 2 lots of the base. We're going to carry that 2 lots of 8 to the next column, and the 5 left over is going to go in our result. And so there goes our 5, and we're going to carry that 2 to the next column. Well, that 2 just lives in a column by itself, and so it's immediately just part of our result there. Okay, so again, just like in our last decimal example, we've not really involved this 4 yet. We've done every combination of 6 times 2, 6 times 5, 6 times 3. Now we're going to do 4 times 2, 4 times 5, and 4 times 3, remembering that we're shifting one place to the left now, and so I'll just preemptively put that blank space in there to remind us. So first up is 4 times 2, and 4 times 2 gives us 8. Now we can't use the digit 8, because remember that the octal system only allows the digits 0 to 7. And so straight away I have to carry that one group of 8, as it were, that one base of 8 to the next column. We just did 4 times 2, so we'll carry our 1 to here. And because we've carried all of that 8, we're left here with 0. Next up is 4 times 5, which is 20, but not forgetting to add that 1, which is 21. And from our 21 again, well, we've already worked out the multiplication of 21 made up of base 8. We've got 2 groups of 8 plus 5. We saw that in a previous section there, so we can use that same formulation again. We can put 5 in our next digit here and carry the 2. Next we have 4 times 3, which gives us 12, not forgetting to add the 2, which takes us to 14. And again, 14, we'll just make a note down the side here, we can say is made up of 1 lot of 8 plus an additional 6 to make 14. And so again, we can enter our 6 and carry the 1 lot of 8, as it were. So there goes our 6 as our digit, and we're carrying 1 to the next column. And that 1 is by itself, so we're just going to add that straight on to our final digit. Just as a side note, these numbers that I'm writing out here down the side, we can also express those. What we're doing really is converting those numbers to the base of 8 in octal form. What we're really doing is writing out numbers to the base of 10, and converting them to the base of 8. So when I say 1 times 8 plus 6, really what we're saying is 1 lot of 8 plus 6 units. So 1/6 to the base of 8. We're converting our numbers to octal. And so if it helps to write them out just as octal numbers rather than writing out the full expansion like that, you can do similar. Anyway, what remains now is for us to find the total, simply adding these two sets of results that we've gained here, and we can do that quite easily. We find that 4 plus 0 gives us 4 in the rightmost column. 7 plus 0 gives us 7. And 5 plus 5 gives us 10. So remember, having to carry the 8 is the same in this addition. We've seen examples of addition in a previous video. But in this case, we're going to have to carry 1 lot of 8 from what would have been 10 and leave 2. In the next column, we have 6 plus 2 now plus an additional 1, which gives us 9. And again, we have to carry 8 from that. Taking 8 from 9 leaves us with just 1. We're carrying another 1 here, and 1 plus 1 gives us 2 in the last column. And so here we have our final result of 21274, remembering that that's to the base 8 with that subscript there. Before we move on to dividing octal numbers, here's a few more examples that you might want to try for yourself. You can pause this video or take a screenshot or similar. But here's 3 worked examples using exactly the same methods to find the results shown. So for this second half of the video, we're going to talk about how we can divide octal numbers or divide in the octal system. And again, just before we get on to an octal example, we're going to just remind ourselves of the method of long division using just a decimal example, just ordinary decimal numbers. And again, you might be more than familiar with how to do this, but just as a reminder of the method, because the method is the same as we're going to be using or similar when it comes to octal numbers. So let's say that I want to divide the number 852 by 3. We're going to set it out in this manner, laying it out as a long division. So the method that we use to do this is to start from left to right and divide our digits within the number by the divisor 3. And so we're starting with 8 divided by 3 and so on. Now when we're doing this division, we're looking for the whole number of times that 8 divides by 3, for example, and whatever's left over is going to be a remainder. So let's take, for example, this first digit, 8 divided by 3. Well, we can think of it in terms of how many times does 3 go into 8? Well, 3 only goes into 8 twice. And what's left over is our remainder. So 3 only goes into 8 twice. 2 lots of 3 is 6. And so we started out with 8. We must have 2 left over. So we can write this as 8 divided by 3 is 2, with remainder 2. So what you'll notice is when we've carried that remainder, we've sort of attached it to the start of the next digit, and so 5 has become 25. So our next division is not 5 divided by 3, it's 25 divided by 3. So how many times does 3 go into 25? The answer is 8. And we're left with a remainder of 1. And so finally, our number at the end is not 2 anymore, it's 12. And so 12 divides by 3 nicely to give us a whole number answer of 4 with no remainder. So we have our result of 852 divided by 3 gives us 284. So again, apologies if that is more than familiar to you, but we're going to use a very similar method when it comes to octal numbers. But again, we have to remember that the base of our numbers in the decimal example is 10, but the base of our numbers in the octal example that we're going to see in just a second is going to be 8, and that's going to have a slightly different effect on this method as we see it here. So here we have an octal example. We're dividing the number 426 by 3. And what I've done is I've just marked each of these with a subscript 8 just to remind ourselves that these are octal numbers, but they're not going to come into our calculations as such. 426 divided by 3 is the division that we're going to try and perform. So we're going to start off in exactly the same method as before. We're going to divide 4 by 3. Well, 3 only goes into 4 once, but we're left with 1 left over. And so we'll mark that on our result here. You can see that 3 goes into 4 once. We've got 1 left over. And so our next digit has become not just 2, it's now 1, 2. So I want to pause at this point because this is a common stage where mistakes are made. The temptation is to say, well, our next division is going to be 12 divided by 3. And the reason why this is a problem is because we're dividing our numbers in a sort of conventional decimal sense, but this number here is not the number 12, because remember we're in the octal system. So what we really have here is 12 to the base of 8. And if you've watched our previous videos on octal numbers, you'll know that we can expand that in the form of 1 times 8 to the 1 plus 2 times 8 to the 0. So if you haven't watched our video on octal numbers, where we introduced the topic of octal numbers, it's worth going back to watch that if you're not sure where this expansion has come from. But 1 times 8 to the 1 is 8, and 2 times 8 to the 0 is 2, because 8 to the 0 is just 1. Anything to the power 0 is 1. So we have 1 times 8 plus 2 times 1. And so as a decimal number, we have the number 10. 8 plus 2 gives us 10. Where subscript 10 to remind us that's our decimal number. So really when we're doing this division here, let's go back to our example. When we have 1, 2 divided by 3, that's not 12 divided by 3. That 1, 2 is an octal number. We have to remember that that's the same as 10 divided by 3. And so 10 divided by 3, well, how many times does 3 go to 10? It goes in 3 times with remainder 1. And so let's add that to our result. 3 with remainder 1. And so for our last step here, we do the same thing again. Remember not to fall into the trap. This isn't 16 divided by 3. This is the octal number 16. Divided by 3, and 16, let's expand that out again, is the same as 1 times 8 to the 1 plus 6 times 8 to the 0, and 1 times 8 to the 1 is just 8, plus 6 times 8 to the 0, or 6 times 1 is 6, and 8 plus 6 is going to give us 14, and that's to the base 10. That's a decimal number now. So again, back to our example, we're not really doing 16 divided by 3, we're doing 14 divided by 3. How many times does 3 go to 14? The answer is 4, with remainder 2. So let's enter the number 4 into our result there. And the remainder 2 has nowhere to go because we've finished evaluating the different digits in our number here. We've got nothing to carry that on to. And so our result is not a whole number result. It has a remainder on the end there. So what we can do is we can finish up there and we can say that what we found is that 426 to the base of 8 divided by 3 to the base of 8 is equal to 134 to the base of 8, remainder 2. Here's a few more examples that you can try for yourself if you like. All of these should give whole number results with no remainder. So you can pause this video and have a go using exactly the same methods as we've seen previously to see if you can get these results too. So I hope you found this video useful on, first of all, a reminder of octal numbers and working to the base of 8, but then to see how we can multiply octal numbers together and divide octal numbers by each other as well.